Hello and welcome in today hands-on about C0 and timers. We will try generate PWM and measure frequency without any impact to core. I show you in 3 steps how it may be used. First step will be simple generation of PWM signal for onboard LED. Then we try periodically change data cycle using second timer and DMA. And last part, it's about measuring of data cycle and period using third timer and DMA. First, we have to create new project in STM32CubeMX or Cube IDE. Now we will create new STM32 project. We will select C031C6 and this one is the best for us. On the nuclear board we select name and now we can create project. At the start, we set timer 1 to generate PWM on channel 1. On this channel it's connected onboard LED and it's necessary set internal clock as source. In practice, we will select timer 1. Clock source will be internal clock and on channel 1 we will generate PWM. Now it's necessary move connection to channel 1 to proper pad on the microcontroller. There is possible use control key. If you press control and then other possible pins are shown by blinking, and you can also use control and drag. And it's simply possible change pin. To make this example more attractive, we will use low-level libraries instead of HAL abstraction layer library, and we must to change for all libraries to low level. Now we can continue with the clock settings. We will use internal 48 MHz oscillator, simple setting. And only we change this press clearer and we will go on maximum speed of the microcontroller. Now we will set the timer for 1 Hz frequency and data cycle 50%. 4799 counter period 4 nines and PWM with period 5000. And now it's necessary use this cheat sheet and to section user code begin to. We will copy the code. Now press this icon to generate code for application. We are here and section 2, it's here. All code is here, only start timer and the generation of PWM. Now we can build and download it to the microcontroller. And if everything is okay, the onboard LED is flashing. And now it's time to set frequency of the timer to 1 Hz for LED blinking. Because mine clock is 48 MHz, we need to divide by 48 millions, and it is divided to parts, 4800 for prescaler and 10,000 for the counter. Prescaler must be set -1, then 4799. For counter it's same situation, 10,000 -1, and for PWM we set duty cycle to 50%. Now we can save changes and generate code, and now it's necessary to copy this code for initialization of the timer to user code section 2, which is here, and it's all what is necessary. Now we can build the application and download it to microcontroller. And if everything is okay, the LED slowly blinking. Now in the second part of our presentation we will change frequency of timer 1 to higher, and we will be change duty cycle to change LED bright. Second timer will be used for timing of changes, and DMA will be used to change duty cycle. First we must activate it timer 16 and set DMA settings for this timer. We add the DMA request for update event, which is shorted to up. I don't like it, but because it's same as up as opposite to down. Transfer will be done. Now we set timer 16 and it's a DMA for work. First we must activate this timer and then set DMA settings. We add DMA transfer from up event, which is update. Transfer will be done from memory to peripheral, word white, and we will use circular mode. All necessary settings are done, and we can continue by change frequency for timer 1 to 1 kHz, which will be done here and here, and then we set initial value for pulse to 0, and then we change settings for timer 16. Prescaler will be same as for 1 Hz, and because now we need 2 Hz, the period will be only 4999. And now we can save and generate code and copy 2 pieces of code to start our changes. Yes, we need generate code. Now we are in part 2. First is definition of data cycles in array. It will be copied to the section 0. And code in section 2. It's larger because we need to start timer 1 and timer 16 and DMA. That's it. Now we can debug. And now in last third section we will try set timer 3 to measure parameters of signal generated by timer 1. We will use combine reset trigger mode with input from channel 1. We will be count internal clock. We will use 2 channels, one to capture rising edge of signal and second one to capture falling edge. Now we enable timer 3 in the combined reset trigger mode. Trigger source will be from channel 1, clock source internal, and channel 1 input capture direct mode and channel 2 indirect mode. For the other settings we are return back to presentation. We will use 2 DMA channels, both from peripheral to memory and half word byte, and both in circular mode. For channel 1 from peripheral to memory, half word and circular, and second one from peripheral to memory, half word. That's all is set, and we can continue. For timer 3 we will be count 1 megahertz. We can count up to full range. Full range. Input capture on first channel, it will be done on rising edge and on channel 1, and for channel 2 it will be connected to channel 1 pin and falling edge. rising edge direct and falling edge indirect set to the same signal. No division. And now we can go to check the pin where is the timer 3 input connected. By default it's on PA6 and it's visible that it is. And now it's necessary simple hardware modification on board. Put the jumper on connector 10 between pins 11 and 13 like you see on this picture. Now, as in previous cases, we add some code. Now we save our set changes in IOC file and generate code. And now we can add new code to control timer 3 in application. First we add two variables where will be stored captured values to section 0 and there is code for section 2 which is larger but still not so much complicated, because we start timer 1, we prepare DMA to change compare capture register of timer 1 and start timer 16, which is triggering this transfer. Then we prepare two DMA channels for timer 3 to capture values, and at the end we start timer 3. And now we can start debug to see if values are as we expected. And now we can see in falling edge the data cycle in number of ticks and in period of the input signal.